session is called Your In-Flight Workflow is called, and they do not want breaking changes. So this is really about workflows. So it helps if you already have used Dapr Workflows before. If not, it can still be, of course, very informational, but maybe some more things are new for you, which is totally fine. Just to highlight the actual problem that I'll be talking about. So we're dealing with breaking changes in workflows. So that's what this session is about. So just to sketch what's going on. So for instance, you have an application with your first version of a workflow, and that's running in production. So in this case, we're using Dapr Workflow. So we have an application running with your workflow code, and right next to it, there's the Dapr sidecar that has the workflow engine. And the workflow engine is talking to a state store because all workflow executions are persisted in a state store. So everything's fine. Then you start working on the next version of your workflow. And what will happen quite soon is that you'll introduce a breaking change. And what do I mean with a breaking change? Well, once you have deployed your next version of a workflow, and you have deployed it, causing some downtime of your previous version of a workflow, there might still be workflows in flight, meaning there are workflows which are still running, so workflows which have not completed or have not failed, so they are still running. When we deploy a new version of the application over the previous version, there will be still state in the state store that are from those V1 workflow executions. And so that's the situation. Down here, we've just deployed a new version, a new application with V2 of our workflow. The Dapr workflow engine is still in between there, but now we still have old state. And once this is up and running again, the Dapr workflow engine will rehydrate the state from the state store, and it will try to complete these in-flight workflows. But now there might be a mismatch between the state here and our new workflow, and that is not a situation that you want to be in. Now, luckily, Dapr Workflow now has like a built-in versioning in there since 1.17, which came out a couple of weeks ago. So that's great. So you can now really safely roll out to production, but also safely continue building workflows, version them in different ways, which I'll show, without breaking any in-flight workflow executions. All right. So what I'm going to talk about is first some Dapr Workflow basics. If you're still completely new about Dapr Workflow, I'll explain my local setup, and then I'll mostly running some workflow versioning demos. And at the end, I'll also be running a workflow application with Diagrid Catalyst to show the very nice workflow visualizations there. All right, so first up, Dapr Workflow. So Dapr itself is a open source project. It's a graduated project within the CNCF. There are not too many graduated projects within the CNCF, so we're really proud that Dapr is one of them. And Dapr provides APIs for building secure and reliable microservices and agentic AI systems. And a lot of these systems these days are based on workflow, on Dapr Workflow, because it really provides like a very nice reliability layer for your microservices and your agents. So the Dapr project is very broad. Dapr contains lots of APIs. We also call them building blocks, and they are listed all here. So I'm not going to talk about many of them. This session is really focused on the workflow building block. And in this case, in my demo that I created, I'm also using the conversation API, which is an abstraction across LLM providers. So talking about Dapr Workflow in specific, so since like a couple of versions ago, the Dapr sidecar now has a built-in workflow engine. Workflows are authored in code, and I'm using C#, but you can also use Python or Java or Go or JavaScript. The workflows themselves, they are stateful, and they should be deterministic because they are replayed many times, and they are, as I showed before, the state is persisted into a state store and is then going back from the state store back into your application. The activities in a workflow, and those are like the basic building blocks. And those can contain non-deterministic code. So what's very typical to happen is, well, you start a workflow with a certain input, and then you run an activity, and inside that activity, you are retrieving some information from a database. And then you are inspecting that output in the workflow, and then you have an if statement. And if that if is false, then we call another activity. And if the if is true, we call this activity. And then we are done. So a workflow contains calls to other activities using different patterns. I'll show you which one soon. And there's business logic in workflows. But other than that, there should not be any other code inside your workflow. So I'll quickly go over the different patterns that you can use with Dapr Workflow. And the demos that I'll be running will use task chaining. That's this one, and also fan out, fan in. So the task chaining is where all the activities are executed sequentially. And it's typically done because the output of one activity is used as the input for another one. So that's why it's a chain of activities. The other thing that I'll do in my demos is this pattern, the fan out, fan in. So in this case, you can execute multiple activities in parallel. So in this case, the inputs are not, or the outputs of an activity are not used as input for another activity. They're all completely independent of each other, and that's why they can be executed in parallel. And the nice thing is that the workflow will actually execute these in parallel, and it will wait until all of these have been completed, and then you can do some aggregation over the results or send the results to another activity before you're done. There's also the monitor port pattern that's really useful if you want to do some work on the schedule. So for instance, maybe you want to run a nightly cleanup job to clean up some cloud resources, and you can do that inside of this activity. And if the resources are not completely cleaned up, well, then we just instruct the workflow to wait a bit. So in this case, let's say we wait for 1 hour. Then we instruct the workflow to continue as a fresh instance. And we can also provide like a new payload for the workflow. So the workflow will actually start from the beginning again. It will check the condition. If it's not met, it will just do a loop. So instead of doing like a do while loop in a workflow, you should always use a continuous new. And once the condition is met, then you can stop. External system interaction is also a very powerful pattern in Dapr Workflow. So you can actually instruct the workflow to wait until a certain event comes into the workflow. And then you can inspect the payload of that event and then do something else inside your workflow. So in this case, we first call an activity, then our workflow will wait. Some other system, that can be a human, that can also be maybe an agent that will raise an event into this workflow instance, and then then this will continue with just execute activity 2 straight away, and then you have the output. The final one I'm sharing here is the child workflow. So instead of putting in a chain of doing a fan in, fan out of only activities, you can also have a parent workflow, and that consists of child workflows. So what we see in this example is we do have the fan out, fan in pattern, but instead of individual activities, we are actually executing child workflows. So each of these child workflows then contain chain of activities again, or maybe they are doing fan in, fan out themselves again. So you can build like very rich and compose very complex workflows using child workflows. Right, moving to local setup. So what am I running for my demo? So the technologies used are Docker Desktop, because that's required, and for Dapr, but also for Aspire, because I'm doing the demos with .NET Aspire. After Dapr CLI installed, I've also initialized that. And when you initialize with the Dapr CLI, you get a couple of Dapr services running as containers. I am using Velky as the state store, which is a Redis compatible state store. Using .NET 10, I'm using the Aspire CLI. And I have the Diagrid dev dashboard. And that's really great if you want to monitor and debug workflow executions, as we'll see shortly. So what I have here is a enterprise diagnostics application, and that will be talking to the Dapr sidecar, which contains the workflow engine, and then the workflow engine will be like pushing workflow state into a state store, but it will also get back that state because it does a lot of check-in, because all of that workflow state will be persisted. So there's a lot of communication going on, which we actually don't see because the Dapr Workflow engine will take care of that. But we can actually use the Diagrid Dev dashboard to actually inspect how this workflow will be executing and where it is. Now, my enterprise diagnostics is not a boring business enterprise, but it's about the Starship enterprise. So this is a Star Trek themed theme demo, and the workflow will do a couple of things. So first, it will do a couple of analysis. So it will start with analysis of the hull. It will do analysis of the warp core, of the security systems. Later on, I will extend it with also the weapon systems. And then there's a step to actually combine the results and also give recommendations on which systems require the most attention. And it will also generate a message to send to the bridge what needs to be done. Now let's have a look at the Aspire project now. So we have this enterprise diagnostics folder, and I have three projects here. So I've got the app host, and we'll dive into that a bit later to see how everything is configured. There's a service default, so those are the default settings and configurations for each service. And then there's the API service, and the API service is what actually holds my workflow definition and also my activities. But I'll show some code later on that. First, I'm going to build the application and run it, and then I'll show the code, how it's all done. So I'm now building the application. It's done. I'm now running Aspire run. So Aspire will now do the local orchestration of all of the services and containers. And I should have a dashboard now. And let's see. No, that's not here. Yeah, that should be this one. Okay, so this is my Aspire dashboard, and that lists all of the services and containers that I have running. So I have this cache, which is my state source, so that will contain my workflow state. I have the Diagrid dashboards running, and I already have it open here. That looks like this. So it will give you a list of all of your workflow executions, and you can actually drill down into all of these and then see all of the steps. These are already completed, so but I'll come back to this when we're actually running a sample. Then I have my workflow application. So this contains my workflow definition and also some API endpoints. And this is then the Dapr sidecar. Okay, let's go back now to this. So now let's start a workflow, because we've started our application. So the application is running, but we haven't started a workflow yet. So I am starting an application by calling to the start endpoint of the application that's running locally, and this is my payload. So I'm generating an ID. I provide the name of the ship, a date, and the name of the engineer that requests the diagnostics. I'm using VS Code extension called the REST client, so that enables me to declare all these endpoints here, and I have this small link button here called send request. I will click that. I will get back a 200 OK with an instance ID. So I get back an identifier of this workflow execution instance. So now we can go back to the Diagrid Dev dashboard, and we can see that it's running here. So here we can actually see this instance. So we can see the input for this. And here we see the execution history, and it reads, you start from the bottom and then read up to the top. So we start this diagnostic workflow, and then the first task was the analyze hull activity. It was scheduled and then completed. You can also expand these, and you can see the inputs and outputs of each of these activities, which is very useful if you're developing these. Okay, so this is all running. It's already quite far now. It's doing the recommendations. But let me go back and talk about the code now. Okay, so we've seen the Diagrid dashboard. So now let's have a look at the app host to see how everything is configured. So this is the app host file in our app host project. And we're using this NuGet package, community toolkit, Aspire hosting Dapr, which allows us to actually use Dapr in Aspire projects. We call this add Dapr extension method. This part is setting up the Velki container, so that will be stored for our workflow state will be stored in there. We do it with data volume, so it's persisted between sessions, so we can inspect that. The next step defines our workflow application. So this API service, which will have like this name, will have a Dapr sidecar with these options. So I set the log level. I also make sure that I set the location to the resources path. So I'm using a couple of Dapr resources. And at the very bottom, there's the configuration of the Diagrid dev dashboard. So it's a container created by Diagrid, and it has some like initial configurations on where to read the state from. Okay, so here's the representation of the workflow that has been running now. So it's a very basic task chaining example. So we start the workflow, and then we do the analyze whole activity and warp core security systems, and then we generate recommendations based on these three, and the recommendations are then fed into the notify bridge activity, which creates a message based on these recommendations, and then we send it to the output. So that's it. Now, let me show you the workflow code for this. So I'm now in this diagnostics workflow file. So yeah, workflows in .NET are just classes. They inherit from a workflow class. And what's happening here is, well, it's important to know that if you want to use application logging, don't inject a logger via the constructor or via the method. You need to create a replace safe logger, because this run async method is being executed many times. So in order to have like a safe logging mechanism, use this create replace safe logger from the context. And as you can see here, we have like a list of all of the activities that we're calling: the analyze hull activity, analyze warp core, security systems. And each of them has an await. So we are actually awaiting when this activity is done. And then we have a result for each of these. Then we combine these into a recommendations input. And we provide that input into the generate recommendations activity, which gives us back the recommendations based on all of the analysis. And finally, we use these recommendations as an input for the bridge notification. So this is our final activity that we're calling notify bridge activity. Then we get a notification back. And the total output of the workflow is this diagnostics output that contains some of the properties of the input, but also the recommendations and the message that was sent to the bridge. All right, so this is the workflow definition. Now let's have a look at one of the activities, because in the activities I'm using the conversation client. So I'm actually making calls to an LLM, which then generates some data for me. So this is the analyze whole activity. We are injecting the Dapr conversation client here, and this is the run async method that gets executed. So you always need to create conversation options when you use the conversation API. So you specify the temperature, right? So how strict or how random do you want the results? You can provide a prompt cache retention, right? So to save some money, it's very useful if you do that. And what's added in 1.17 is structured formats. So you can actually specify the response format to be structured in a specific way, which is really great, because before we had this response format, I had to put in lots of information in the prompt, but now I got rid of that, and I can specify this response format. Just to show you briefly, it's quite verbose. It uses these protobufs, well-known types, to specify the exact format. So yeah, there's quite a lot of code to define your response format, but it works. So I have these options, and then I'm using these options in the conversation client and calling the converse async method. So it takes a conversation input, which is a list of conversation message. So I have a system message here, which is like a general indicator of the system. So you are a Starfleet engineering diagnostic system for the Starship hull. And then I have the user message, which is a bit more defined and specific for this request, right? So perform a hull integrity analysis, and then, okay, well, the things that we want to have analyzed. And I'm also specifying here what I expect. So the result is a JSON with system name, status, issues array, and health percentage. So this information is still there, but it's not as verbose anymore as it used to be. So I get back the response, I deserialize that, and then I get the property names and give it back into a typed result. So as you see, there's no reference here of which underlying LLM provider I'm using, right? So I'm using the Dapr conversation client, but we don't see what is the actual LLM. So that is specified in a conversation component. So that's this YAML file here. And as you can see, I'm using Anthropic here under the hood. And we're using the Claude Sonnet 4.6. All right, going back to the program CS file of the workflow application. So here we have registered some things. So we are using the Dapr Workflow package. We're also using a Dapr Workflow versioning package. So more details on that later. And also the Dapr AI conversation extensions package. So the conversation extensions enables us to use this method to be able to automatically inject the conversation client into the activities. And then the Dapr Workflow package is used to actually register our activities. So all of the activities are here, which are used. Notice that there's not a registration for the workflow. Previously, you still had to register your workflow, but now since the arrival of this workflow versioning package, which is used here, you don't need to register your workflow. It will be automatically registered for you. And then there are some endpoints here. So there's a start endpoint I just called, and that's using the workflow client to schedule a new workflow. So we're always starting this diagnostics workflow here. And we get back the instance ID. And there's some other methods to get back some the status and also to pause it and resume it. But I won't be demoing that. Okay, so the application has been running for a while. So let's actually get back to this, because this should be finished by now. Yes, so now our workflow is finished. We can see it's completed. There's an input, there's also an output now. So this is the complete output of the workflow. So we see like a list of recommendations for the hull and for the warp core, for the shields, and also priorities, right? So there are some critical things which need to be adjusted, and there are also some less important things. And we see the complete execution history, right? So if I scroll down, so here is the workflow starting, and then we see per activity that has been scheduled and completed for each of those. All right, we can now stop this application, and now let's make a change. So let's open the workflow file again. So that's this one, diagnostic workflow, and now let's introduce a change, but let's introduce it in a safe way. So I will add an activity. So I have automated that. So here we go. So I've now added a call to the analyze systems activity. So that was not there yet, but notice that it's wrapped in this line. So if contact is patched. So this is provided by the versioning package. So if for any in-flight workflows that are still going through this workflow now, this will return as false. And so for any old data that's still in the state store and that's been running through this new version of a workflow, right? Because this is something new that we introduced. This will result in false, so it won't execute this. So it won't interfere with old data. But for any new request that this workflow will handle, this will result in true. So new requests will actually go and analyze this, call this analyze weapons activity. So it will also be included in the recommendations input. And for any of the ones which were already started before this change, it won't be in the recommendations input. Now, since we added an activity, we also need to register that activity. So let's do that here. And now let's run the batch application. So I'm running Aspire again. And there we go. Okay, it's up and running. So let's see if everything is green. Yeah, everything is green. That's good. And now let's start the workflow again. And starting is, just using the same input again, using the same payload, we get like a new ID. So let's start this. And now we have D9A. So now we can actually go back into the dashboard and go back here. And here we see D9A. So it's running. It will take a while before it's completed. I'm not gonna wait for that. So I will switch back to VS Code and actually stop executing this program entirely. All right, so the patch versioning method is really useful for introducing like small changes, right? So this was a small change. We just introduced like one activity call, and that's it. So patching is great for introducing small things in like an existing workflow. Now let's see if you want to make a bigger change. So right now, the workflow is like a task chaining, right? So everything was in sequence, but in fact, all of these analyze steps are like, they don't have a relation to one another, right? I don't have to map the output of the analyze hull activity to the input of an analyze warp core activity, right? So these can all be executed individually. So it's better to use fan out, fan in, because the workflow will be much more efficient. So this is our second version of the workflow. We use fan out, fan in for all of these 4 systems, and then the rest still remains sequential, because here we do rely on sequential operations. So this is the V2 of the diagnostics workflow, and notice that it's just the file. It's basically a copy of the same class, but now I've named it V2. So also in the class name, it's labeled V2, and the content is now different. We still have all of these calls to analyze hull activity, but we don't have the await in front of it. So the Dapr workflow engine is not executing this yet. We just have the task definition of calling this activity. So we have defined all of these tasks, and at this line, this is where the magic then happens. Here we instruct the Dapr workflow engine to first fan out, so execute all of them, but then we also instruct the workflow to actually don't continue just yet. We only continue when all of these tasks have been completed. And when all of these are done, then we can actually extract results from all of these activities, and we can put them into the recommendations input and continue as before. So let's run this V2 version. I'm running the same Aspire run command again. And notice that even though this is labeled V2, this class, when I make, I'm still calling the same endpoint, and the same endpoint is still calling or starting the diagnostics workflow. So notice that I don't have to call diagnostics workflow V2 here, because we've added this Dapr workflow.versioning package and added the versioning in the program CS. So this application is aware that there are multiple versions available of your workflow. So I'm calling the same endpoint now again. There we go. So now we're looking for 7E6. So let's switch to this again. And here we see 7E6. And if I drill down into that, so here you can already see that it's using the fan out, fan in method, because now we can see a task scheduled for all of these 4 activities, and one by one they will now be completed as well. And it's now already going to the generate recommendation activity, so it's also a lot faster than the previous edition. All right. I don't think we need to wait until everything is done. No. Okay. So let's stop this V2 application. So now you've seen like 2 ways of doing versioning, right? So the first is patched, is great for like small changes, but using a sort of copy of the workflow and then changing that and renaming that to V2. So that's really ideal for like bigger changes, right? And yeah, and going from a task chaining to fan out, fan in is quite of a big change. So that's why I decided to name this V2. Now, this versioning package that I've added is smart enough to understand like V2 is bigger than V1, etc., but it's also smart enough to know that V10 is also bigger than V2, right? So it's the .NET SDK maintainer did a good job there. So it's using this version naming as the default strategy, but you can actually use different strategies when you do versioning. You can also do versioning based on semantic versions and also based on date times. That's all documented in the Dapr docs, which I'll share at the end. All right, let's have a look at Catalyst now, because we've seen things locally now, but Catalyst offers a really great visualizer of workflow executions. Here we go. Catalyst. Oh, let's get rid of this. So Catalyst is an enterprise platform that provides durability and security when running workflows, AI agent, and MCP service. The great thing is that it gives an identity to all of your services and workflows and AI agents. So it really, you can do very like granular scoping from how which service has access to what other service, etc. It really makes your systems fault tolerant because it's based on the Dapr Workflow engine. And it really provides very deep insights into workflows and agentic systems. And it also captures all of the historical executions. So you get really very rich visualizations, which I'll demonstrate. So the local setup with Catalyst is quite different than before. So I'm still using Docker Desktop, not because I'm they need it for Dapr, because we're not using Dapr sidecar model anymore, but I'm still using Aspire. Still using .NET 10, still using Aspire, but now I'm also using the Diagrid CLI to log in, and also there's an Aspire integration that also needs this. So we still have our enterprise diagnostic service, but instead of talking to a local Dapr process, we're now talking to Diagrid Catalyst, which has a built-in workflow engine based on the Dapr workflow engine. And we're also using a Diagrid Catalyst state store there. All right, so now I'm updating the dependencies because I'm actually updating my current project to this new system. So I'm removing some of the dependencies I had before. So I'm not using Valkey anymore. I'm not using the Dapr toolkit anymore. And I've added a Diagrid dependency now. Let's also update the app host. So our app host is much cleaner now because we don't have to add the Valkey integration and the Dapr sidecar. The only thing we have now is a Catalyst project with a project name. Let's do this, and we have to make sure that we enable the managed workflow, so that we should be set to true. And here we have our workflow application, and we say, okay, use this service, but then with Catalyst, and then provide this Catalyst project to it. So and this is available because we created this Diagrid Aspire hosting.catalyst package. Now this is still very, very early days for this package, so I'm hoping that it works. Nothing is guaranteed yet. If it doesn't work, I'll fall back to another solution that doesn't use Aspire. But let's see. So first, I need to log into Diagrid because we will be accessing a cloud service. So I need to be authenticated against that. So I'm confirming this. All right, we are authenticated. Excellent. And now first let's have a look at the workflow, because also this workflow is now at V3, which is a step up than we had before. So one thing that you can do to actually improve the reliability and resilience of your workflows is providing retry options when you're calling activities. So what you can see here is this call activity async, so that has like an option for workflow task options, and we are providing we're getting that from this method. So if you just click on this method, so this gives back a workflow task options, and that contains a retry policy. And I've now configured a workflow retry policy that has that will attempt, if an activity fails, it will attempt it for 5 times in total, and it will have a first retry interval after 3 seconds, and it uses a backup coefficient of 1.5. So it will the retry interval will incrementally increase with a factor of 1.5. So I'm adding that those workflow retry policies to all of the activity calls, all right? Because especially when you're making calls to LLMs, these things might be not available, or they might result in something that you can't process. So it's always good to include these retry policies. Okay, so let's try running this again with Aspire. And connecting to app host, starting the dashboard. Okay, so let's see if this is working. Okay, I will wait like 30 seconds. If it's still in starting mode, then we switch back to my alternative. Because typically the first time will be a bit slower because it needs to provision a project and then an app ID, which is the identifier. So the first time will be slow, but I already ran this before, so it should be a bit faster. but I don't think it is at the moment. Let's see if anything in the logs. No, that's not there yet. Okay, in that case, I will show you an alternative. So let's stop this, and I will show you an alternative. Okay, so I have another solution, which is also a .NET 10 solution using the same workflows, everything. It's just not an Aspire project. So that's why I changed to this folder. I will do the Diagrid login again. All right. Okay, that worked perfect. Now let's run this project using the Diagrid CLI instead of running it through Aspire. So now to make a connection with the Diagrid backend, and it will start our local application. So it's doing it now. And once it's running, okay, yeah, so now it's connected and we see it's building. Okay, so the application is now up and running and also connected to the Diagrid backend. So now we can actually start a workflow here and then switch to the visualizer in Catalyst. Okay, so I'm sending the request again to the same endpoint, so nothing really changed here. Okay, so we're looking for 956 now. So now I'll switch back to Catalyst, and this is Catalyst. Let me increase this a bit. So there's a workflows a menu item here. So click that. And here you see our diagnostics workflow. And well, we now see total executions 5 because I've run this before. But if we click on here, we see like an overview of all of the different executions. But here we can see, okay, I'll need to zoom out a bit because it's otherwise too small. This is our latest one, the 656. So if we click on that, then we actually see this very nice visualization of where the workflow execution is now. So it just completed all of the fan out, fan in analysis activities. It also just completed the generate recommendations, and it's now calling the notify bridge activity. And as you can see, this visualization is of course very nice, but you can also drill down into this, right? So you can click on activity, you can see what the input is for this activity, and what the output is. So this gives you just a bit more information in a nice visual way than the Diagrid dev dashboard. And you can also see how long all these activities took. And now this one is completed. Okay, so I can now stop this application. Perfect. And I can get rid of this. All right, so doing a little recap. So right now, since Dapr 1.17, we can now really use the versioning, proper versioning for Dapr Workflow. So versioning in .NET, you do that with the dapr.workflow.versioning package, and it's I think it's a very rich experience, right? To either use the patching for small changes or use like name versioning for larger changes. Different Dapr SDKs use like a different way to configure these. So for .NET, it's really very minimal what you need to do. For instance, for Python and for Go, it's a bit more explicit what you need to do, but everything is pretty well documented in this workflow versioning docs. Let me actually also share some links with you. I'll just get it out of here. Yep. Oh, that's not the link. Okay, it's in the later slide. Just 1 second. Right, yeah, so here are some resources for you if you want to try this yourself, and I will share them as well here in the chat. So this first link to Diagrid Labs, so that's our playground for all of the public stuff that we do at Diagrid. So it contains lots of demos. So this one is called Dapr Workflow Versioning. You can check out all of the code that I've just shown and ran. Then the next one is the link to that explains the Diagrid dev dashboard. that's really an essential tool if you're working with Dapr Workflow. Another thing I want to share is Dapr University. So if you're still relatively new to Dapr, that contains quite some nice lessons that really gives like a good introduction without the need of installing anything locally. So you can get like a sandbox, sand-based, cloud-based sandbox, and there's like a Dapr 101 lesson, there's a Dapr Workflow lesson, and there's a Dapr Agents lesson, and there's like a Catalyst 101 lesson. So definitely check that out. And of course, please try Catalyst yourself, right? So Catalyst provides really nice, reliable workflow engine for your agentic systems or for plain workflow systems, with also a very nice visualization for both workflows and agentic systems. All right, and that was it, everyone. So yeah, I hope you enjoyed this and got some more inspiration on running workflows and maybe combining workflows with agentic systems as well. If you have any more questions, feel free to either ask them here now, or you can also join the Dapr Discord and ask away there. We're going to do quite some few webinars in the following 2 or 3 months. So I think next week, I think there's already another webinar about Dapr agents. Yeah, so please stay tuned, have a look at the Diagrid.io website for upcoming webinars.